All right, so we're working on an enumerate function challenge. We're going to write this function here called alt series. And basically, we're essentially going to run three accumulators sort of in parallel. I'm saying that in quotes, air quotes. But the basic idea is that essentially, instead of just building, a for loop accumulator where we're just summing one quantity, we're essentially just going to we're going to have three accumulators, sort of summed together in the same for loop. Okay, so we need a variable called alt sum, a pow sum, and an index sum, and we have a parameter called numList, which is just a list of numbers. And let's see. Very, very important note here. The summation index should start at 1. And this is just, this isn't like a rule in general. This is just what this challenge is specifying, that this index should start at 1. Okay, and then we get some example test cases here that we can use to verify our own solution. So I'm going to work on the solution in just VS Code. You're more than welcome to just write your code in the little code box that's provided here, but I prefer to write in my text editor that I know all the nice keyboard shortcuts and it's got syntax highlighting that I like better than the syntax highlighting on Learn. So I'm just going to paste my solution into Learn when we are ready. Okay, so first I'm going to define our function. Okay, and so we have alt sum equals 0, pow sum equals 0. So I'm establishing these accumulators. All right, and so the point of this challenge is to use the enumerate function. So for index value in enumerate numList, and then remember, we have this summation index should start at 1 criteria here. And enumerate, if you see here, we've got this pop-up in my IDE that's saying there's a second parameter here. So the first parameter is the iterable that you're enumerating over. So it could be a string, a list, a tuple. And this is just the general type of that thing. You don't need to worry about that. But then it also shows this second parameter here, the start parameter, and that's just the value we can start. We can specify that the index should start at. So I could say let's start at this index. Why not? And enumerate will just work fine, and it's not gonna, we're still gonna go through each value in numList in order, but we're just gonna be calling the indexes or the indices, starting at this arbitrary value that we pick. So for this one, we're just gonna start with 1. That's the most reasonable. And right, so we're doing an accumulator. So alt sum. First, we're supposed to, let's see. I'll do like a more basic pattern first. So if, let's see, alt sum so even indices should be added and odd indices should be subtracted. Okay, so if index mod 2 equals 0, so that means the index is an even value. We're going to go alt sum plus equals value, else alt sum plus minus equals val. All right, and then we'll just do the other two. So pow sum plus equals, and that's going to be the result of raising each value to the power of its index. Okay, so val raised to the power of the index. And then index sum is going to be each index raised to the power of the value at that index. Index sum plus equals index raised to the value, raised to the power of the value. Okay, so yeah, so let's see, just a review. If the index is even, add to alt sum, and alt sum, by the way, means alternating. It's short for alternating because we're alternating, right? We're adding and subtracting, and we're alternating between the two depending on whether the index is even or odd. Okay, and then we have pow sum, so value raised to the index power, and then index sum, index raised to the val power, value power. And then we just need to return in the order alt sum, pow sum, index sum. All right, and let's go ahead and add these function calls in here just to make sure. That we are doing everything correctly. So I'm going to run this. Okay, 4,330 and then 66,282. So that looks good. And then 0,410 looks good as well. Okay, so I'm going to take our solution, paste it in. Before we go, I'm going to actually go over some, so we can see that we finished the tests and everything looks good. But before you go, I want to actually go over a couple of sort of optimizations that we can make here. So one thing to notice is, or rather not to notice, but to kind of, hopefully you'll start to think this way and think about maybe ways you can add like mathematical tricks to functions like this, which are largely mathematical. So one thing to know, I'll jump into a Python REPL here real quick, is that -1 raised to an even power, and 0 is even, by the way, is +1, and raised to an odd power is -1, right? So right here, what we can do is take advantage of this fact and actually get rid of this if-else branch right here. So what I'm going to do is I'm going to, oops, did not mean to do that. I said I know all the keyboard shortcuts. Okay, so alt sum, and then we're going to plus equals -1 raised to the index power, and then multiply that by val. So what this is doing is this is switching between -1 and +1 depending on the index value, right? So the index value is starting at 1 for our particular case. So the first sort of coefficient, if you will, -1 raised to the index power is going to be -1. So we're going to subtract value at first from alt sum. And then the next index value, or the next iteration, is going to be an index value of 2 right here. And then we're raising -1 to, squaring it. So it's going to turn positive. And so that means that we're going to be adding val. So right here, what we're doing is just multiplying the value of whatever val is, whatever this number is. And maybe I'll change that to num. That's a little bit better of a naming, variable naming there. Okay, so we're taking num from num list and we're multiplying it by either -1 or +1, depending on the parity of the index value. And by parity, I mean even or odd. Cool. All right, so we can, well, I'll leave that there and then jump out of this jump out of the REPL, run this again, and what happened? We've got two print statements here. Somehow both of those are missing their closing parentheses. I don't know how that happened. Okay. Yeah, and so we can see we're getting the same results. But now our solution is a little bit cleaner, right? We don't have to deal with an if statement. We can do, and this is, a little bit more efficient because we're not doing these additional Boolean operations. And actually modulo, right? Because we're doing modulo here to check if the index is even or odd, and then we're doing an if-else check. So it's a Boolean and an arithmetic operation. So two extra operations that we've kind of just gotten rid of. So just a micro optimization. And there's not much else we can do here other than one thing we can do. This isn't really necessary, but we can use tuple unpacking to just kind of clean it up and remove some lines. Whoops, index sum. So 0, 0, 0, this is a tuple on the right side. This is the same as putting this in parentheses. And then we're just unpacking this tuple right here. So just kind of making it a little bit more compact. And notice I'll run this again just so we can see that nothing changed. We're still getting the correct results. And then I'll just put this in here just to show that we're also still passing all the tests. All right. And you can see here, the first sort of iteration of our solution is here. And then we show this sort of micro optimization that you can make. And there's a little bit more explanation there if you were still curious. Okay, see you in the next video.